Welcome to another late night lecture. Tonight it's going to be on mass wasting, chapter 15. So, not necessarily in Florida, but slopes are common elements in our physical landscape. They may appear to be stable, but because they're above flat ground, they're under the influence of gravity. And at any moment, material can move down that slope, and it can be gradual or, really slowly, almost imperceptible. And on the other hand, it could roar downhill as a debris flow or a rock avalanche coming down at really high velocities. Okay, and these are geologic hazards. A landslide is a sudden event where a lot of rock material, debris, regolith, soil just comes down a steep slope. And when humans are in the way, when roads are in the way, when cars are in the way, that's a natural disaster could occur. Okay. So mass wasting really refers to the downslope movement of rock, regolith, or soil under the influence of gravity. Mass wasting is a process that often follows weathering. So as rocks are exposed at the Earth's surface, they undergo chemical or physical chemical weathering. And that material weathers and then is transported under the influence of gravity. It can be carried by wind or water, and ultimately that is transported to the lowest spot on Earth, which is the ocean. And the combined effect of mass wasting and running water on the surface of our landscape produces the stream valleys, okay? And that's one of the most common landforms that we see on Earth. Look at this one. This is absolutely amazing. This is the Narrows in Zion National Park. Those canyon walls are over 2,000 feet high, and you can hike through them. It can get dangerous. If it rains there, which it doesn't often rain there, but flash floods can occur, and that can be kind of dangerous within there. But a lot of the hike through the Narrows includes wading through river water like this. But it's very impressive. Okay, and if you look at the work of running water kind of eroding through a landscape, a great place to witness this is the Grand Canyon, and looking at the excavation that this water did over millions of years. And the Colorado River has just kind of eroded a lot of material on the Colorado Plateau. So here, all this material you can attribute to the work of running water. Maybe a little bit more because you have meandering rivers kind of going back and forth, but all of this is eroded away by running water. And then here, these are kind of steep slopes, okay? And then when these sedimentary rocks weather and they mass waste, this material flows downwards under the force of gravity to the Colorado River, and then the river carries it out to the ocean or depositional environment. But this is a lot of material. Like if you were to find out the volume of this, it would be a lot. I'm sure the book estimates it in some capacity, but some areas of the Colorado River, or I'm sorry, the Grand Canyon, are about 18 miles wide at its widest, okay, and about 1 mile deep. I'll let you guys do the math, okay? And these slopes, they kind of change through time, okay? The most rapid and spectacular type of mass wasting events occurs in areas where there are young mountains, really rugged terrain, okay? Because there's a lot of thrust faults and rocks being pushed up high to oversteepen slopes, okay? And that creates, kind of pushes rocks really up high, higher altitudes, so there's more velocity associated with them falling under the force of gravity, okay? And then essentially over geologic time, these events, mass wasting and erosional events, they change the environment into these kind of rugged mountains that you would see in the Himalayas to more subdued terrains like you see in the Appalachian Mountains. Okay. So gravity really is the controlling force of mass wasting, but there are other important factors that play roles. One is water. Okay. When sediment has a lot of space in between each and other sediment, and it fills up with water. And initially, water is cohesive and kind of makes the sediment kind of stick together in small amounts. But once you start kind of adding more and more water, it eventually becomes a lubricant. Okay, and in addition to that, water is kind of heavy. If you ever fill up a bucket full of water and try to carry that, that's heavy. You know, if you ever go to the beach, you ever build sandcastles at the beach? Yeah, a little nostalgic moment right there, right? In order to build a sandcastle, you have to do it with damp sand. If you do it with dry sand, you're wasting your time, and this is all you're going to build, right? Little ant piles, right? But if you have a little bit of water, it creates some cohesion, and the sand grains kind of stick together. So initially, water in a small amount is kind of cohesive. But once you start adding too much water, then you get a slurry of wet sand, and it all falls apart. Essentially, water becomes a lubricant. And the reason why that's important is because that's a trigger to many mass wasting events. Look at this aftermath of this mudslide. This road is completely covered in rock, material, soil, and mud from the adjacent mountain, and this stuff just roared down the slope and deposited out here. This is a big mess, and this can destroy homes, it can kill people, cause a lot of property damage. There's a YouTube video link down there. I recommend clicking on it. Sometimes the links won't work because they change or have been updated. But if that doesn't work, it's definitely worth it. It's a mass wasting event. If it doesn't work, in YouTube, type Taiwan, landslide, rain, those 3 keywords. Click on it. It's totally worth your time. It's kind of Final Destination style stuff. Okay, another trigger for mass wasting events, like a trigger meaning like something may occur to kind of cause a mass wasting event, because mass wasting events can occur out of the blue, you know, like landslides can just happen without any real trigger to it. But a lot of times mass wasting events or landslides can occur because there's a trigger. And the first one I mentioned is water. Really, if there's heavy rain and heavy rainfall, that can add a lot of weight to the material on the side of an oversteepened slope and lubricate it, and that can make that material kind of move under the influence of gravity downhill. And that's what you'll see in that YouTube video in Taiwan. Another trigger to mass wasting events is just an oversteepened slope, okay? Many times, like, rivers cut through, like, or create valleys, and if they're at the headwaters of a river in really high elevations, they'll cut downwards and create oversteepened slopes. And because, like you saw in the Narrows on the Colorado Plateau, that could create a situation, those canyon walls are an oversteepened slope. That could create a situation where under the influence of gravity, if there's a crack in that rock from a joint or something like that, it could come tumbling down. Humans also create oversteepened slopes. Anytime we live in mountains, a lot of times we'll blast the side of the mountain to put up to pave roads. You usually create an oversteepened slope by doing that, or building homes or communities. So we often do that. Okay. When you have unconsolidated material, and you just pour it on the ground somewhere, they'll create what we refer to as an angle of repose. This is like the maximum angle it'll pile up on without having a mass wasting event. Okay, so meaning like the material's stable. So if we look at this picture here, this is an industrial plant where they're piling up sand or debris, and this is the maximum angle this material will lay on the ground at without having to flow down. Like if you were to pour more sand here, it'll just run down this angle to the bottom. Okay, so that's the angle of repose. And that's dependent on how big our planet is, because depends on the force of gravity exerted by the material on the land surface. Interestingly, Mars is a smaller planet, So its angle of repose is actually larger. You can pile things up higher on Mars because there's less gravity. Just random facts. Okay, so here's an example of an oversteepened slope. Somebody built a house on the side of a mountain, right? And here's the oversteepened slope. And all it takes is perhaps a little bit of heavy rainfall, adding a lot of weight to the ground around here. It soaks into here, adds a little bit of weight, lubricates it, boom, and then you get a mass wasting event. And that poor barn house is suffered a lot of damage. Another trigger to mass wasting is removal of vegetation. Okay, plants do a really good job of, like, their roots kind of go into the ground and hold the soil there. Trees as well. It binds that soil and regolith together, so it prevents these mass wasting events from occurring. Okay, so if we kind of clear out an area, cut down the forest, or remove vegetation for whatever reason, their roots aren't going to hold that stuff down anymore. So that can trigger a mass wasting event. A lot of times, it doesn't necessarily have to be human activities. Like if there's a forest fire that will burn through an area. This happens a lot in California. There's a forest fire or a fire, a brush fire. It'll destroy all the vegetation on the side of the mountains. Then there's, that vegetation is not holding the regolith and soil anymore. So all it takes is some wind, perhaps, maybe even an earthquake, some seismic waves, or a little bit of rain, and then boom, all this stuff comes down the mountain. Okay. In the western United States, wildfires are inevitable. They have fire seasons. It happens all the time. So that's a common trigger to mass wasting events there. In fact, if you go to YouTube and just click on California mudslides, you'll see a number of events occurring after brush fires and stuff like that. Okay, so here are those fires, which are very dangerous. Okay. Earthquakes are also triggers to mass wasting events. If you have a hillside, so we're going to go back to California again. There's a plate boundary there. There's a San Andreas fault, and if there's any movement on that fault, generates an earthquake. Then you have seismic waves kind of propagating through the crust, and that shaking, that ground shaking, will cause mass wasting events. So that's a very common trigger. There's some examples here. The 1994 Northridge Earthquake triggered about 11,000 landslides. So think of it as the ground shaking and then everything, unconsolidated material, just kind of moving down slopes. Okay. In 2008, there was an earthquake in China that caused landslides. And a lot of times this material will move downhill and maybe even block like a river valley, and it can create a lake. So we refer to those as earthquake-created lakes. Okay, and then there's liquefaction. We've talked about this before. Liquefaction essentially is when you shake the ground up, especially if it's unconsolidated material, especially if it's kind of saturated with water, it becomes like quicksand, and things can kind of fall through it, which is incredible. So here is an example of a landslide here. So this is an oversteepened slope, and all this material just under the influence of gravity moved downhill very quickly. And if there are any buildings in the way, they're going to be damaged, and property can be lost and lives can be lost. But landslides can occur without any triggers. A lot of mass wasting events just occur. And the material just slowly moves, imperceptibly slow, until one day it just gives way. Okay, and the timing of this is completely random, and that's why they can be very dangerous and scary, and because of their suddenness and just occur at any given moment. And so the prediction of these events are practically impossible. Okay, the two things scientists use to classify mass wasting processes, there's more than two, but the two right here are just the type of material and the type of motion. Okay, the type of material, it's either debris, mud, earth, soil, or regolith, or if it's just rock coming down the slope. Okay, and then the motion. Okay, whether if it's a fall or a free fall of detached pieces of rock, that creates talus slopes. Okay, let's take a look at that. All right, so here are some examples of talus slopes. All right, so we have some exposed rocks on the earth here. They're undergoing weathering. Mass wasting is the collection of that debris on these slopes here. So it's just a lot of unconsolidated material. Broken pieces of the rocks up here are kind of depositing down here. It makes them kind of hard to walk up because it's a lot of unconsolidated material. You know, you kind of slip a little bit, fall back as you're climbing this. It can be kind of dangerous too, because you can knock over a rock, and then that can kind of roll downhill. I know what you're thinking. You heard the doorbell ring? Yeah, I got a package. Okay, so the type of motion for mass wasting events, you can have a slide, which is where you have zones of weakness within the crust, very shallow within the crust, and material slides along those zones of weakness. And there's a couple different types of slide. There's a rotational slide, and then there's a transitional slide. I'll show you pictures of both, okay? Then there's a flow, and a flow occurs when the material's saturated with water, okay? A viscous fluid just kind of flowing downhill. Okay, and then we classify them based on the rate of movement. And there's some really fast and crazy mass wasting events. Rock avalanches are the fastest type. They're the most rapid mass wasting events. And essentially, it's rock material coming down an over-steepened slope at really fast speeds. And this can like crush cars, bury people, bury roads, bury villages. There's some like really sad cases of Lahars, and those are flows or mud flows that have covered entire villages, okay? And as these rocks, and specifically a rock avalanche, which is pretty crazy to think about, the rocks will come down the over-steepened slope, and they'll actually glide down air, or air acts as a lubricant and helps the rocks kind of move downhill, which is pretty bizarre to think of. Because essentially, as the rocks fall, they trap air underneath them, and then basically use it as a medium to travel along with, which is pretty weird to think about. Other type of mass wasting processes are much slower, okay? I'll show you examples of this, but one example is called creep, and particles move just a few millimeters per year, okay? A millimeter is 1/100th of a centimeter, and a centimeter, 2.5 centimeters is about an inch. So this is really small stuff. All right, here's an example of a rock fall. Often when you drive on an over-steepened slope in a mountainous area, they'll warn you about this. Although, like, I don't know what you could possibly do if it was happening. They're so quick. Giant boulders kind of just falling down an over-steepened slope. Okay, here's an example. This is crazy. This was the Black Hawk Rock Avalanche. Okay, so this is out west in California. And here's the deposit, the rock avalanche deposit, okay? All of this material here. It's between 9 and 30 meters thick, depending on where you are. It traveled a distance of 8 kilometers. This is where the material, a little higher uphill where the material came from, traveled 8 kilometers in an instant, really. And it was lubricated by the air underneath it, and then all this material kind of deposited over here. Okay, so it raced down slope, and what lubricated this movement was compressed air underneath it. So if you were in that way, yeah, that would take you out. You'd be buried. Okay, a slump is a type of mass wasting event, and it occurs. It's a rotational slide. Okay, so it can involve a single mass of material or multiple blocks. And it typically occurs in over-steepened slope. Let me show you a picture here. This is an over-steepened slope with a road on it, okay? And then all this material, which was once here, moves along a concave surface. So it moves along this surface, so it's a rotational movement. And we refer to this as the slump block. So this entire block moved downwards, and it created a number of scarps that you can see here, okay? And then this material we refer to as earth flow. So it's just material that moved down in this way. Maybe there were fences here or something. So that's a slump. Here's a slump in California. All right, their coastlines often have cliffs, very different from Florida. And so here are their little tiny beaches and coves and stuff like that. But essentially here are the scarps that formed as a result of a slump. This material moved downwards. We can't see the, but underneath there's a curved surface where this stuff kind of moved downwards. Okay, and these are people's homes. These are, I'm assuming, very expensive homes. Here's a road really close to the highway. And a lot of the homes and roads and places that are this close to the coastline, there's a risk of this occurring, okay? Because this is the oversteepened slope. It doesn't help too, like if there's storms, the waves come in and hit this material and cause it to kind of landslide downwards. Okay, rockslide is another fast form of mass wasting. These are dramatic, okay? They're very fast and destructive. They can be triggered by precipitation, and so that's why they're most common in spring. The water or snow provides a lot of weight and lubrication. Occasionally, they're triggered by earthquakes. Some notable ones, Gross Vent and Yellowstone and New Madrid. Here's an example of a rock slide. So we have rocks outcropped in this area. Okay, they've, under the influence of gravity, moved down and collapsed, covered an entire area. Here's one event that occurred in 1925. The scars from this landslide are still visible today, but this material moved down a hill and covered a river that once flowed in this direction. Since this event, the river has kind of cut through the material and continues to flow, but at the time, it blocked all this mass wasted material blocked the river and created a lake. And what was crazy is there were a lot of vacation homes here, so they kind of blocked this area and created a lake. So the river maybe, oops, excuse me, let me erase this. What is going on here? Okay, so the river once maybe was like this wide, right? And there were homes like here and here, and so when the river was dammed, the water came in and flooded the homes here, and some people came back to see their homes floating in the middle of the lake, which is pretty crazy. Okay, so sometimes this material can kind of create temporary lakes. All right, another rapid type of mass wasting is debris flow. And this is when you have material from an oversteepened slope that's saturated with water. Okay, sometimes we call them mud flows, very common in California. Also fall into that YouTube rabbit hole of mudslide California. You'll find some cool stuff. Okay, so they often occur in semi-arid mountains. Why this occurs there? One, there are a lot of wildfires there that strip the mountainsides of vegetation, which allows for more higher risk of mud flows. And also, because it's semi-arid, there's less vegetation to begin with. And that lends to more mud flows. And when there are rain events, which don't happen very often, but when there's torrential rains, it'll cause these debris flows. Okay. So a lot of times they're confined to channels or canyons, but they can cause a lot of damage. Look at this. Here's a debris flow. You can see this is a channel where the water would flow through, and then it kind of deposits out here. So if you have homes here, look at that. That looks like a nice car, one of those like old time cars that a family member fixes up and is like, oh, it's my baby. Yeah, well now it's full of mud. Okay. Well, these homes, look at this. This is the roof of a home, completely gone. Okay. And all this mud coming into a house is pretty crazy. You can see some videos. I oftentimes in my in-class lectures will show videos of debris flow coming into people's homes, and they're recording it, which is pretty crazy. In one case, a person kind of went up the stairs to their second floor and watched all the stuff come in, and you can see the video. The mud piled up to the level of their kitchen counters. Okay, that is a mess to clean up. Okay, and then there's Lahars. Lahars are just the same thing, debris flows, but that just come down of volcanoes. And this can happen This can happen just from precipitation events, snow or rain, but also from volcanic eruptions. Often we have a lot of snowpack or glaciers at the tops of volcanoes, and if there's an eruption, it'll heat up all that material and melt it. And volcanoes are kind of not that well built. A lot of times it's unconsolidated volcanic material kind of sitting at the top, and there can be sector collapses or just an avalanche of unconsolidated material downhill. A really sad event occurred in 1985 in Colombia. Nevado de Ruiz is a volcano there that erupted, and there was a debris flow, or lahar, that inundated an entire town, and about 25,000 people lost their lives as a result of that. Okay, and these also generally flow downstream channels. This is a satellite image post St. Helens eruption. Okay, so this is Mount St. Helens here. Okay, and then this is the plot of the debris flow flowing down one of the channels, and the deposition of all this kind of volcanic unconsolidated material just deposited out here. Okay, and you can see that this is a satellite image. It's all this dark, muddy material. Okay, here's another image of some of the lodges surrounding the volcano that were near the channels and stream beds that were just inundated by muddy material. And in some cases, the flow was so high that it knocked over bridges. Okay. Now let's talk about kind of like some of the slower mass wasting events, or the slower types of mass wasting. Earth blows, they usually occur on like humid kind of hillsides. I don't know if you've ever seen this, but some people sometimes have like saturated water in their lawns, and it creates this weird situation where it traps a bunch of water, and it looks like their grass is like a water bed, and then they have to like pop it, and all this water pours out. It's very similar to that. So water really saturates the soil, and it's usually soil that has a lot of clay and silt, so it kind of traps the water. And so it moves at really slow rates. Okay, some can be hundreds of meters wide. Let me show you a picture. Here's a sketch of one, but this is an earth flow. Okay, all this material just got saturated, created a small little scarp, and this material just oozed downwards. Okay, so it's all this material. So that's earth flow. Then there's creep. Creep is a much slower moving mass wasting event. And it's really just gradual millimeter by millimeter movement of material downhill. And this typically occurs in areas where there's like a freeze and thaw, like during the day it's warm enough for water to thaw, and then overnight you get freezing. And water kind of expands when it freezes, so it's this expansion, contraction, day and night type deal. Okay, so that freezing and thawing causes the movement of material. So when it freezes, it expands. When it thaws, it contracts, and freezes, expands. And this happens kind of daily, or whenever this occurs, expansion, contraction. And this stuff slowly creeps downhill, millimeter by millimeter. And so what happens is that this pressure kind of will bend rocks in this direction, which is pretty crazy. Let me show you an actual picture. That's just a sketch. So here's the sketch. Ominously, they put like gravestones here that are collapsing. Ooh, scary. But here are those bent layers. Look at this. These are near vertical layers of rock, and they're bending this way because of the creep that's moving in that direction. It can also curve tree trunks. Maybe you've received an email from somebody or something that's like, hey, this Bulgarian forest is haunted. Oh my God, right? Yeah, that's, because they're like, oh, there's ghosts in here and all the trees are curved because of the spirits. No, it's a geologic process. Okay, it's creep. It slowly, the soil moves, and then what happens is the trees, as a result, kind of grow in this truncated fashion. Okay, you can have retaining walls that are kind of jerry-rigged fixed like this here. And this material just slowly creeps downhill. Still causes a lot of tension cracks, right? And that's because, again, an over-steepened slope. All right, there's other slow movements. This stuff happens in areas that are very cold, closer to the Arctic Circle. We call this solifluction. This is the downslope movement of soils that have a lot of water in them. So water is always involved. Solifluction translates directly to soil flow. So this happens in areas where there's permafrost. Permafrost are areas where you don't want to live. But essentially the ground is permanently frozen year round. Okay, so you can't really dig anything down there. Like it's essentially like if you were to throw a pickaxe on the ground, it'll just, you know, strike hard rock essentially because the ground is frozen. Right, and that's year round, even in the summers, right? But in those areas, in permafrost, the upper kind of few centimeters, only in the summer will become the active layer, where it kind of thaws a little bit. And so the ground is frozen from here on down, but the upper layer is active in the summer. And then over the summer, it kind of moves along atop the frozen layer, okay? And that's because it's thawing and stuff like that. So this kind of, do you see this? All this material is kind of slowly moving downhill. This is solifluction. This is near the Arctic Circle in Alaska. Okay, so it's like kind of melting soil, like off Freddy Krueger's face or something, like kind of slowly coming downhill. Notice there are no trees, right? Trees can't, the roots can't go through this permafrosted layer. So yeah, that's solifluction. All right, and then in areas of permafrost, we find them typically, you know, in the Arctic Circle, so north of 60 degrees latitude, okay? And so the deep ground remains cold, like colder than 0 degrees Celsius, so below freezing. And summers are too short and cool to melt any of the ice below the surface, and they're extensive in the Arctic Ocean, okay? And a lot of times land use, we prevent certain types of land use to prevent permafrost from melting, because it's a very sensitive habitat, which is changing because of global warming. But here, the areas in white are the areas that are permanently frozen, okay? And then here's the discontinuous zone where there can be, during summers, active layers, okay? Or some thawing in the permafrost, okay? But these areas are diminishing as a result of global warming. Okay, and the last type of kind of mass wasting event that can occur, and if you ever live in places that are really far up north, when you build your homes, there's specific zoning rules that you have to, like the base of your house, or if you have a fireplace or anything that generates heat, it has to be well insulated at the base of the home, because you don't want any of that heat to travel through the bottom of the house and into the ground, because you're building on top of permafrost, right? And if there's any heat that's coming off of your home and goes into the ground, it's going to thaw the permafrost. And when you thaw the permafrost, then you'll have some subsidence. So this happens a lot to a lot of homes here. When you have excess heat coming off of your home, you thaw the permafrost and your house sags. Okay, and that's pretty crazy. Look at this. This house is sagging downwards, and it's no good. It's no good. It melted the permafrost, and that's a big problem up there. Fortunately, yeah, we don't have to deal with something like that here in Florida, but this is a common occurrence when you live north of the Arctic Circle.